All right, one of the nice things about continuity is that we can use it to determine if a function is solvable over a given interval. We're going to use the intermediate value theorem to do that. Now, the intermediate value theorem doesn't necessarily just relegate us to determining if something is solvable. Essentially, if you've got an interval a to b, and you know that f of b is greater than f of a on a continuous function, that means that there's got to be a point C that's in between them. So using this to determine if something is solvable is if your function can equal 0 at a given point, it's solvable. So if you find that at the endpoints, one is below 0 and the other is above 0, that means over the course of the interval, it must be able to be 0 at some point, or at least one point. Now, I've given you a polynomial here, 3x to the fifth minus 4x squared equals 3, and we're going to determine if it's solvable over the interval 0 to 2. So I'm going to rewrite this real quick. So let's say f of x equals 3x to the fifth minus 4x squared minus 3. So f at 0 is just negative 3. But f at 2 is equal to 3 times 2 to the fifth minus 4 times 2 squared minus 3. 2 to the fifth is 32. 2 squared is 4. 4 and 4 is 16. And certainly 3 times 32 is going to be larger than that. So this is going to be, this is less than 0. And this one is going to be greater than 0. We can solve for this. This is what? 96 minus 16 minus 3. So 77. And again, that's greater than 0. Thus, by the intermediate value theorem, IVT for short, f of x has a solution on the interval 0 to 2.